Okay, hello and welcome to today's lecture. This is Math 1D. This is our very first lecture. We are on chapter 14, 14.1, and we're going to talk about functions with 2, 3, or more variables. You can find lecture notes on Canvas. Very well. 14.1, page 1. Okay, very well. So what is a function? You learned about a function in algebra, in pre-calculus, in calculus. A function is a machine. You plug in some data, some values to that machine, and it makes some changes to your data, numbers, values, and it gives you some other outcomes, values, or numbers. So a function is like a machine, especially for those of you who are in computer science, machine learning, you just plug in some information, some huge data to your machine, to your algorithm, to your program, you train that program, and it gives you some outcomes, which you plug in some data, digits, numbers, it changes those data and gives you some new data. So the values, the data that you plug into the machine belong to the domain of the function. Here you have your machine, your function. You have some data entering the function and some outputs. Inputs in the domain and outputs in the range. Very well. So in algebra, in pre-calculus, in Calc 1A, 1B, 1C, you learned about function in one variable. Why do we say one variable? Because you have only one free variable that you can actually change. You don't have two different free variables. You don't have three different free variables. So recall that a function in one variable, this is a free variable. Why do I say free variable? Because you can freely change the values for that one variable. Like x is denoted by y equals to f of x. X is independent from y. X is your free or independent variable, and y as the second variable depends on your x. Depends on x. Okay, you all know that for a function y equals to f of x, you have a domain which is a subset of real line. Domain of f of x is a subset. Remember the notation of being a subset, subcollection of R, all real values, and also range of f of x is also a subset of R. Again, R, what is R? R is real numbers. And this symbol is subset or sub-correction. Okay, definition of a function in two variables. In two variables. So you might say, hey, professor, we have two variables here. Unfortunately, we are referring to free variables, not just in general variables. So if you want to write it officially, you can say that, hey, function in two free variables. So let me add it here for you. Free or independent variables. It means that you can freely change two variables instead of just freely change one variable. A function in two variables is denoted by f of x, comma, y, in which x and y are independent variables. Independent or free variables. Okay, very well. So instead of having just one free variable, you have two free variables. So your domain is going to be a subset of plane. X and y are points in x, y axis. You have x axis, you have y axis. The domain of a function in two variables is a subset of Cartesian plane or just a plane. So this is, for example, going to be the domain of your function. Your function f takes one point x, comma, y in the domain. So this is your domain, 1 point x and y. The function takes this point. Take a look at the function itself. F of x and y. It means that it takes points, not just numbers. Here you plug in one number and it gives you an output. Here you plug in a point, x coordinate, y coordinate. So the domain is a subset of xy plane and it maps the domain into R. This is f of x, comma, y. Again, the domain is a subset of the plane. This is your domain. And range is a subset of R. So how do we write it down? I don't like this R. More beautiful. Better R. So the domain of f of x was a subset of R, just the real line. The domain of a function in two variables is a subset of plane. How do we write it in mathematical format? The domain is the subset of, this is Cartesian product between R and R. As you know, x-axis is R, y-axis is also R. So it is a subset of R squared. R to the power 2. I'm going to explain what is R to the power 2. R to the power of 2 is just plane. X, Y, plane. And the range is a subset of R, real line. So let me just write down what r squared is. So in math, we are always interested in generalizing the idea. This is r, which is either x-axis or y-axis. You have negative infinity to positive infinity, 0 is in the middle. Then we say that, hey, this is just one-dimensional thing. We're interested in having a two-dimensional thing, like r and r. X-axis, y-axis. Infinity, negative infinity, and infinity. So somehow we have to define this new object, two-dimensional object. We say that, hey, r cross r, or Cartesian product between two real lines, is the set of all points x comma y such that x and y are just real numbers. X and y are real numbers. Since it's the cross product of r and r, we assign exponent 2 to it. And we say that this guy is equal to r squared. So I expect you to ask, so if we consider the space, we can have r, which is r to the third power, and we have our points in the space, three-dimensional space. So r to the third power is Cartesian product between r, and we call it Cartesian product. Perfect. So we are still on page 1. We're going to go over an example. So before going over this example, let us take a look at this. Recall. Suppose you have a function in one variable. Let f of x be square root of x. How do you graph this function? What's the domain of this function? Recall that for a square root function, the domain is equal to the set of all values, all numbers like x, such that x is greater than or equal to 0. When you have even indices like 2, 4, 6, and so on, inside the radical can never be negative. It's either 0 or positive. So you can generalize the idea by forming a function in two variables and using square root, the fourth root, the sixth root, and so on. So in this example, we have this function. The function is given as f of x and y. You have two free variables. It's defined as square root of x plus y plus 1 divided by x minus 1. The question says, find f of 3 and 2, and then sketch the domain. Very well. Okay. We have a function in two variables. First, we want to evaluate the function when x is 3 and y is 2. The order is important. Here you have ordered pair. X is 3, y is 2. So wherever we see x, we write 3. Wherever we see y, we write 2. Not that hard, just evaluating. This is equal to square root of 3 plus 2 plus 1 divided by my x is 3, 3 minus 1. So on my numerator, I get square root of 6 divided by 2. So what's the meaning of that? It means that you have a point on the graph of this function. It means points with first coordinate 3, second coordinate 2, and last coordinate square root of 6 divided by 2 is a point on the graph of the function. You have x coordinate, you have y coordinate, you also have z coordinate. So when it comes to the graph of this function, you get a surface in three-dimensional space, in this space. We're going to talk about graphs later. Sketch the domain of the function. Okay, take a look at this function. First of all, you have square root. Second of all, you have an expression on the denominator. So you have to be careful about two things. The first one is square root. The second one is the denominator. Note that for the numerator, you have square root of x plus y plus 1. So x plus y plus 1 must be greater than equal to 0. For sure, we know that. There is no doubt there. You saw this guy in algebra. It's just an inequality. This guy says y is greater than or equal to negative x minus 1. We're going to graph this on the other side. Also, note that x minus 1 is on the denominator. So x minus 1 can never be 0. We don't have 0 on our denominator. This is how we define the domain of the function. So x is never 1. So this is the analysis of our domain of the function. But the question says, sketch the domain. Okay, let's try to sketch the domain, see what's going on here. To sketch the domain, first of all, we have y greater than equals to minus x minus 1. This is just an inequality. You can graph y equals to negative x minus 1 and then select all the values for x and y such that y is greater than equals to negative x plus minus 1. So here you have x, here you have y, x-axis, y-axis. So if I plug in 0, I get negative 1. If I plug in 1, I get negative 2. If I plug in negative 1, I get 0. So this is my line here. Okay. It says y is greater than equals to negative x minus 1. I can use 0 and 0, the origin, as the checkpoint. If I plug in 0 and 0 here, it says 0 is greater than equals to negative 1, which is true. So it means that the origin, or 0 and 0, is part of the solution of this inequality. Very well. And it says x cannot be equal to 1. Guys, x is not 1. It's not just a number. It's actually a vertical line. Also, x is never 1, is a vertical line. So let us find x equals to 1 and just eliminate that from the domain. So this is the domain of your function. As you can see, the domain is a subset of xy plane. We expected that because we're plugging x and y for the function. Very well. Let us move on to the second page. We have a checkpoint. We have a different function in 2 variables. It's ln function. Again, a little bit of recall for you. For the function y equals to ln of x, remember that when you graph this function, the graph of the function is like this. This is your x-axis, this is your y-axis, and this is your ln of x. So the domain of this function is all values greater than 0. If you have any other quantity, any other function, like function g, you set that function greater than 0. So domain is equal to the set of all x values such that x is absolutely greater than 0. So if you have y equals to ln of like g of x, then the domain is equal to all x values such that this guy, this function, instead of having just x, you're replacing that by another function like g. Gx is absolutely greater than 0. We learned this in pre-calculus and calculus. Now for our checkpoint, this is our checkpoint number number 1. So it says, suppose you have function f of x and y equals to x times ln of y squared minus 1. First of all, what is f of 3 and 2? And second of all, sketch the domain of the function. Okay, so first of all, how do we evaluate the function? We know our x is 3, our y is 2. We just plug that in. This is equal to x is 3, so I have 3 times ln of y squared 4 minus 1, which is 3 times ln of 3. So this is my final value. To see what is this number, we have to use a calculator to get a decimal number. I'm going to leave it as it is. But what's the meaning of that? It means that the point, so point 3, 2, 3, ln of 3 is on the graph of the function. Sketch the domain. Okay, so this is the product of x and ln. I don't have any problem with x. X can be any number. It can be 0, it can be negative, it can be fraction, it can be radical. I don't care. But when it comes to Ln, I have to be careful about the quantity inside parentheses. Note that this quantity cannot be 0 or negative.
Professor, I think the equation.
Okay, so it seems like checkpoint 1 has x. Should we leave it as 1 or x? What do you think? Do you want me to solve it with 1 or x?
Either or.
Either one. Okay, let's solve this one, then we solve with x as well. Okay, perfect. So sketch the domain. Here you have a y squared minus 1 must be positive, so y squared must be greater than 1. Okay, how do you solve this? You can say that, hey, I have y minus 1, y plus 1, it must be positive. So if you form that little table with negative 1 and 1 for y, 0, negative, plus, plus, 0, negative, negative, plus. So you get a positive, negative, and positive. Then you have just y. It's not very hard to visualize this. Y squared minus 1 is inequality. It's positive for x, for y value, between negative infinity to negative 1, and also y greater than 1. So it is positive for negative infinity to negative 1, union 1 to positive infinity. So if you want to visualize this, this is your x-axis. Again, you don't have any problem with x. This is your y-axis. So your y, negative 1 and 1. Y is 1, and y is negative 1. So you're going to shape the upper side of line y equals to 1, and also below y equals to negative 1. So in the note, checkpoint 1 actually has x. That was a good review. Okay. So x is 3, y is 2, x is 3, and y is 2. Ln of 4 minus 3, you get 3 times ln of 1. Ln of 1 is equal to 0. 3 times 0 is 0. So what do we know about this function is the point 3, 2, and 0 is on the graph. And let's talk about the domain of the function. Okay, so again, we have Ln function. The quantity inside parentheses cannot be 0, it cannot be negative. So since we have Ln function, it means that we have to take the quantity, whatever it is, and set it greater than 0. Y squared minus x must be greater than 0. Okay, how do we graph this function? What is this? So to graph y squared minus x greater than 0, first graph function y squared minus x equal to 0. So if you graph this function, it is y squared equals to x, or x equals to y squared. Then use a check point. If the origin works, use origin, otherwise you can use any other point. X-axis, y-axis. Okay, very well. To graph this function, this is your function, y squared equals to x. Note that here you don't have any equality. Since we don't see any equality here, what's the meaning of that? It means that the points on y squared minus x are not actually on the curve. So we're going to use a dotted curve. If you have equality, you're going to read it as it is. But since there is no equality here, you're going to have a dotted curve here. Okay, now let us use a checkpoint, like 1 and 1. If I use 1 and 1, 1 minus 1 is going to be 0. So 1 minus 1 is 0, but 0 is not greater than 0. It means that right-hand side doesn't belong to this inequality. It is left-hand side. If we use the origin, it doesn't give us anything meaningful because it gets 0 minus 0 greater than 0, but we already used a dotted line here, dotted graph here. So let us use other points, like 1 and 1. 1 minus 1 is 0, which is not greater than 0. It means that 1 and 1 is not part of the solution for this inequality, so you have to shape left-hand side. Excellent. So let us go through the second checkpoint. We have another function for you. We are still on page 2. Okay. Checkpoint 2. The question says find the domain of you have function g of x and y equals to square root of 9 minus x squared minus y squared. Okay, guys, take a minute or two. Think about this question. Note that you have square root function. It doesn't matter if it has only one independent variable or more than one independent variable. Yeah, because I'm trying to give it a chance to students to think about this, then go over the solution together. That's why we call it checkpoint. There's a literally the example, but I try to give the opportunity to students to think about these questions as well. Very well. So, what do we have here? We have square root function. You have a square root function. Whatever is inside the radical must be greater than equal to 0. So since we have a square root function, 9 minus x squared minus y squared must be greater than equal to 0. Remember that. When you have x squared, y squared in an inequality or in an equation, try to figure out if it's a circle or not. So add x squared, y squared to both sides, you get x squared plus y squared less than equals to 9. Recall that. Equation of a circle is x minus a squared plus y minus b squared equals to r squared. This is a circle centered at A and B, A comma B, with radius r. This is your circle. This is your radius r. Okay. X squared plus y squared. We know that a unit circle is x squared plus y squared equals to 1. If A and B are 0, it means that your circle is centered at the origin. When you say, okay, x squared plus y squared is like greater than or equal to 1, it means that you're looking at the points outside the circle. This is the graph. This is your unit circle, and this is x squared plus y squared greater than or equals to 1. So if it says less than 1, it means that you're looking at the points inside the circle, which is in this is the case that we have here. Here you have x squared plus y squared less than or equals to 9 or 3 squared. We have a circle with center at the origin and radius equals to 3. Okay, perfect. The origin and a circle with radius 3. And these points, x, y coordinates, x, y points are all inside the circle, less than or equals to 3. You can use a checkpoint as usual, like the origin, 0 and 0. A checkpoint, like 0 and 0, 0 squared plus 0 squared, which is 0 is less than equals to 9. So we're going to shape all points inside and on this circle. Okay, on page 3, we have the definition of the graph of a function. Very well. So we are on page 3 of 14.1. So first of all, recall. How do you graph a function in one variable? How do you define the graph? The graph of function y equals to f of x. with only one free variable is the set of all points in xy plane such that they satisfy formula y equals to f of x, or equality y equals to f of x. We can generalize this definition and define a graph of a function in two free variables. Graph of function z equals to f of x comma y. The graph of a function in two variables is the set of all points x, y, z. So instead of having just x, y, we're going to have three coordinates, x, y, and z, such that they satisfy the equality z equals to f of x comma y. Okay, in each case, you can use mathematical format and write it this way. Graph is equal to the set of, in two-dimensional space, 2D, all points x comma y, such that y is f of x, and in 3D, graph of the function is defined as the set of all points x, y, and z, such that z is equal to f of x comma y. So when we use curly brackets, we read this the set of. So the set of all points. The set of all points such that with the condition that this equality is true, such that with the condition that this equality is true. Okay, that's how we officially define graph of a function. So nowadays, we don't use pencil and paper to graph functions. Instead, we're using a graphing calculator, or we're using different softwares or online calculators. Let me share one of the online calculators that you can use to visualize your functions in three-dimensional space. For example, you can use this website. Let me share the link with you. Yes, Mathematica is one of them. Yeah, very good. They have a lot of different websites or softwares to visualize the functions. So this is one of them. You can either use this online graphing calculator, which is very good, or this one, or this one. So there are many of them. So for example, you can graph function square root of 9 minus x squared minus y squared. As you can see here, you have a surface in three-dimensional space. So note that these surfaces, they continue both sides. So if you change the range of x and y, you can actually see how they grow. They never stop. They all continue all sides. We can just add as many digits as we want or zeros as we want here, and you can actually see how it behaves. It's going to continue on all sides.